Good everyone, welcome to my YouTube channel, ECN Made Easy. So today we'll be talking about ISLM, how to derive their curves and the slopes, and explaining explaining the curves dynamics. Okay, before we go to what we have to do today, we'll be talking about ISLM. Now IS means investment savings, and LM means liquidity preference, money supply. Now it is a macroeconomic framework that explains the interaction between the real economy, that is the goods and services, and financial markets. It was developed by John Hicks in 1937. Now IS is a downward sloping curve, just like a demand curve, while LM is the upward sloping curve, just like a supply curve. IS shows the combination of the interest rate and output, where total spending is equal to total output, whereby LM shows the combination of interest rate and output, where money demand is equal to money supply. Now, since we know about all the theories, now let's derive the IS and LM curves. So first of all, we're given our equation as y is equals to c plus I plus g, and c is equals to a plus byd, and I is equals to io minus ir, then t is equals to to minus ty, yd is known as our y minus t, which has been given, and g is our government spend, which is also go. For our money market, we have m, the money demand for money is equals to KOY minus K1R. Then our supply for money is equals to MO all over P. So the question says we should derive the IS and LM curves, determine the slope of the curves, integrate the two curves, and the dynamics. So solution. First of all, we are going to get our we all know that this is the formula, right? This is the model, right? So we have C is equals to, for C now we have A plus BYD. So we have A plus BYD plus our I is what? IO minus IR, right? Plus our GO. Now don't forget that this additional information where YD is equals to this and T is equals to this. So let's input those values. Now we have A plus B into bracket y minus, now our value for t has been changed to to minus ty with a big bracket plus io minus ir plus go. Now we expand the bracket by saying a plus beta y minus to plus ty plus io minus ir plus go. We still expand the bracket again, saying beta, multiplying through by beta y minus beta to plus beta ty plus io minus ir plus go. Now this is a like term, this is a like term, and this is a like term, so collect all of them together. So we're having y minus by beta y minus beta ty, that is equals to a plus io plus go minus beta to minus ir. So to make sure that you didn't do any mistake, you calculate the variables 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. Okay, so that's correct. So factorizing here, we're going to have y is equals to 1 minus beta t, which is equals to rewriting what we've got there. So next thing we'll do is we differentiate. So what we'll do next is differentiate constant. Differentiating constant. And you will agree with me if you solve a numeric question to this variables with this model we're dealing with, you agree with me that these values from here to here are all constant. So we differentiate because we have the y equal 1 minus beta t is equals to the partial derivative of the constant minus I dr. So differentiating that out, we'll be left with 0 minus I dr. Now divide through by dr here, dr over dy. But the twist here is that 1 minus I. Normally, if we're going to divide through, we're meant to be having this one as this one is supposed to be the bottom, and this one is supposed to be this one is supposed to be at the top. Oh, sorry, this one is supposed to be in the bottom. This is supposed to be at the top. But because of this variable, it shows the relationship between our as our interest rate over our y. So it is always going to be this variable over our I. So now, as you can see, this is our IS. Our IS curve. Why this part of our question is our IS, our slope for IS. I hope that's right. This is our slope and this is our curve. Now you can see here that your rate of interest has a negative sign here. It shows that okay, there is a negative sign which follows the rule of downward sloping. It shows a negative sign, a downward sloping curve. Okay, now next we go to our goods market. For our goods market, we know that MD is equals to KOY minus K1R, then MS is equals to M over P, that's our price. And so we have, to get equilibrium, we have MS over MG is equals to MS, right? So we're having KOY is equals to, we have KOY minus K1R is equals to MOP. Now we differentiate constant. MOP is a constant. When we solve a numeric value, you see that the MOP is a constant. So we are going to differentiate KO dy minus K1 dr is equals to GMOP. Differentiating constant out to be left is 0 dy minus K1 dr is equals to 0. KO dy is equals to K1 dr. So we're going to do like we did here. We're going to get the same. We're going to do the same, follow the same pattern. The r over dy would give us KO over K1. Now this value here is our LM slope, and the value here is our LM curve. Now you can see that unlike the answer here we got here, it has a negative sign. That's why it's a demand sloping, negatively sloped. But over here it's a positive slope. That's why it's a supply curve. It has the shape of the supply curve. So let's go to the next question. So the next question says we should integrate the two curves and explain its dynamics. So to do that, we have our, sorry, my hand is not that straight. So on the y-axis we have our rate of interest R, and we have our y over to this end as our real output. But in a normal graph, our y is always at this end and our x is supposed to be at this place. But for this model, our y is below and our r is above. So we draw a straight line down. Don't forget, negatively slope, downward slope is our IS curve. Then we'll draw a straight line up, positively slope, that's our LM curve, right? So now Okay, let's do this. At equilibrium we have RO. At equilibrium here we have our YO. Now interpreting the dynamics, you can say that if there is an increase in the rate of interest, right, it leads to a smaller so interpreting our dynamics that we have here, we have R as our rate of interest over this end and Y as our output, real output. So as we've said, negative sign downward sloping to negative side is our IS curve, and upward sloping positive to our LM curve. Now I was explaining about the equilibrium. This point here is at equilibrium. Now at R1 LM IS is usually less, while LM is usually high. Let's just call this, let's call it maybe Y, let's just call it YA and YB. Out of this Y1 and Y2. Okay, let's use Y1 and Y2, and this is R1 and R2. So, but when the rate of interest is low, you can see that the LM is always high. Sorry, the LM is always low and our IS is always high. Now let me go over this again. The dynamics is that, okay, if there's an increase in the rate of interest, your IS curve is usually low and your LM curve is usually high. But if there's a decrease in the rate of interest, your LM is usually low and your IS is usually high. So just like a change, if there's an increase in R1, that is a rate of interest, IS will reduce, LM will increase. That is, the money supply would increase because of the interest rate has increased. Okay, I think all these are the dynamics that are in the curve of IS and LM. Don't forget, number one, it's negatively sloped. IS negative slope, LM is positively sloped. It's a demand function, demand curve. Sorry, it's a demand curve. LM is a supply curve. So increasing in the rate of interest leads to a lower IS but a bigger LM. While a decrease in the rate of interest leads to a smaller LM and a larger IS. Okay, I hope you understand. Okay, now continuation from the equation that we solve now. We've been given this question, and I think this is a very simple and straightforward question that would have helped everyone. The question says about output is equals to consumption plus investment, where consumption is equals to 100 plus 0.yy, then I is equals to 120 minus 5i. Then in our money market, we have our money supply is equals to 120, money demand is equals to 0.2y minus 51. We find our IS curve, LM curve, and the equilibrium level of income and interest. Then we can interpret that in our graph. Okay, let's get to work. Now solution, y is equals to c plus I, right? Then we have our y is equals to c is what, 100 plus 0.8y plus 120 minus 5i. Color like terms, bringing the y's together. 0.8y is equals to 100 plus 120 minus 51. If you go back to where we get our equation formula, you can see that this part now are constants where we derivated. Okay, but we're not deriving that right now. We're just going to go straight to number solvings. So y, there's an invisible one here. Hope you know. 1 minus 0.8 will give us 0.2y, which is equals to 220 minus 5i. Now I'm going to divide through by 2, 0.2, 0.2. So our value for y here is equals to 220 divided by 0.2, which gives us 1100 minus 5 divided by 0.2, which gives us 25i. Now you can see here now that y, our real output has a negative in relationship with your I. That's why it's in a negative. That's the negative relationship. That's why it's a demand curve. It looks like a demand curve. Now for our money market, for our money market, we have the equation as, equilibrium here is ms is equals to md, right? And our m is, okay, our md has been given as 0.2y is equal minus 5i is equals to 120. So making y a surrogate of the formula, we are having 120 plus 5i divided by 0.2 divided by 0.2 divided by 0.2. So cancel out, so we have our y is equals to, so 120 divided by 0.2 gives us 600 plus 25i. You can see this time around, this has a positive relationship. Now it is clear that there is a positive relationship between y and I, which shows the supply, which shows supply curve property, where there is a positive relationship, whereby it's sloping up. So now to get equilibrium, we know that, okay, y is the same function as y here, right? So y is equals to y. We bring the two functions together, saying 1100 minus 25i should be equals to 600 plus 25i. If we bring both times together, we're having 500 is equals to 50i. Making I the surrogate of the formula, we'll be having 500 over 50, which is equals to 10. So you can use that as 10% or 10, whatever you would want it to be. Then now to get the value for our y, you pick either the IS curve or the LM curve to work out the value for y. So we're going to pick the LM curve because I think that is like, that one has smaller values. So I have 600 plus 25 into brackets 10. That is 600 plus 25 times 10 should give us 250. So we're having 250. So y, so the final answer for y is plus 600, that is 850. So we can have 850 output. So that is the equilibrium. Now to make our work more professional, let's interpret this working into a graph. Don't forget, this is our real output, that's our y value, and this is our r value, that's the rate of interest. So we have this value as our is, lm. So the equilibrium here, we have this to be 850, and the value for this point here is 10%. So then you can interpret your question by saying, okay, when interest rate is, according to the model given or the question given to us, when interest rate is at 10%, the real output is 850 at the equilibrium point. Thank you so much for watching the video. I hope you learned something. Please like and drop comments and also subscribe till we meet again.